A useful visualization for numbers is the number line, and I can draw it like this, a straight line, and we can start off with a line for 0, and then 1, 2, 3, 4, 5. I'm trying to evenly space them out. And then 10 be there, and so on. And you can see that I drew arrows to the left and to the right. That's because this actually continues to the left. We'll talk about more of those numbers in a later video. And I continue them to the right as it gets bigger and bigger. 11, 12, 13, 14, 15. All those are contained on the number line. I just can't draw them infinitely. So I use arrows to show the pattern continues. And you can show any number on here, right? If I wanted to show 2 on here, I would just draw a dot on 2. And that means I've graphed 2 onto the number line. That's what I'm talking about, is 2 right there. Okay, now addition, subtraction, multiplication, division, these are operations, and specifically they are binary operations. That means they take 2 inputs, 2 numbers, and they produce a single output. When you combine the 2 numbers using one of these, 4 operations, you get an output. There is some cases where they don't give you an output, namely division, but that's what you expect. You expect 2 things that you're working with, and then you do the operation on those 2 things, and you get a single output. So adding is just counting together. If an item costs $20 and then another item costs $35, then the total cost is going to be 20 plus 35. If we count that together, go 20 and then 35 more, 20, 21, 22, 35 more from that, you're going to count up to 55. So on the number line, it looks like the number 20. And then if we count up to 55, or we're just going to count, 1, 2, 3, 4, 5, 6, 7, 8, all the way on up. And then there's going to be 35 spaces between them. So 20 and 35 more gets you up to 55. That's the idea on the number line, how you can visualize it. Subtraction is kind of the opposite, where we have, we're asking how far apart are the 2 numbers. Here we're counting together the 2 numbers, so they come to a bigger sum. And subtraction will find a smaller sum because they're asking how far apart the 2 numbers are. If I have 100 and I spin 62, then what I have left is 100 minus 62, or 38. That's how many dollars I have left. So on the number line, we're going to have 100 up here somewhere, and then we're going to have 62 down here. And if you count the distance between them is going to be 38. And so subtraction, right? This was what we were trying to find. Whereas in addition, we were trying to find what's the number that's 20 and then 35 more gives you 55. That's what addition found. Subtraction found the distance between these 2 numbers, which was 38 in this case. Addition and subtraction are called inverse operations. They can be kind of rewritten as one or the other. So in this first case, right, I had 20 plus 35 equals 55. I can also write 35 equals 55 minus 20. I haven't really used any different numbers. I've just used a different operation. We're really talking about the same thing as this one and this one, these 2 equations. The same thing for this one, right? We have 100 minus 62 equals 38. I can rewrite this as 100 equals 38 plus 62. It's kind of the same thing as this equation here. I'm using the same numbers. I'm just using addition instead of subtraction to show that relationship. Okay, multiplication just repeats addition. So 4 items that cost $5 each is the same thing as 5 plus 5 plus 5 plus 5 or 4 times 5. And that's, of course, going to cost you $20 to buy those 4 items. On the number line, we can start at, let's do 0 up to 20. And we're going to have cut it in half and then cut it in half again. So the first item is this one. This is item 1. And then the second item, the third item, and then the fourth item. So all together, we would count them up, right? We count one item would be $5. 5 plus 5 is 10, plus 5 is 15, plus 5 is 20. Or you can just do, there are 4 sets, and each one is $5, so it can be 4 times 5 is 20. That's the idea of multiplication on the number line. There are a few ways to write multiplication. You can use the X symbol. Commonly, and I will write this, I will use the dot notation where I just put a dot between them. So that's 8 times 7. Computers will see a lot of asterisks. That says 8 times 7 as well. You can also just put the two numbers together in parentheses. That's 8 times 7 or 8 times 7 here. If you're right next to each other, that means multiplication in mathematics. So different ways to understand and write multiplication. Okay, division just splits a number into equal parts. So 3 items that are all equal in value that cost $33 each would then cost 33 divided by 3, which will give you $11. So each of the equal valued items are each $11. That means it's $33 total. So on the number line, right, if we have 0 here and 33 up here, if you wanted to split this into equal parts, so I'll just estimate where that's going to be here and here. Then what we'll find, if I did this correctly, what we'll find is that if we count this up, this part, and this part individually, if we count the distances of those, we will see that there are going to be 11 in each one. So I've evenly split up 33 into 3 equal parts, and that means that each one is 11. Division also has 2 different ways of writing it. We can use the division symbol, but more commonly, as you continue in mathematics, you will see the fraction notation here. That fraction bar with the 416 divided by 5 written vertically. Once again, multiplication and division are also inverse operations. So for this first one, we had 4 times 5 equals 20. I can rewrite this as 4 equals 20 divided by 5. Same kind of relationship that I'm showing there with the same numbers, just a different operation. Here I said 33 divided by 3 is 11. That's the same thing as saying 33 equals 11 times 3. Same relationship, just using a different operation. And you can do that because multiplication and division are inverses, and then addition and subtraction are inverses. Okay, if you're on estimated payments for utilities at $100 a month, how much do you spend in a year? Well, there are 12 months in a year. So we can do 100 plus 100 plus 100, where we do this 12 times, but repeated addition is just multiplication. So this is the same thing as 100 times 12, which will give you $1,200. Okay, now I've been showing addition and subtraction, multiplication, division by hand because I've been using simpler forms of that, some simpler pairs of numbers. You can do all of these things by hand, but in general, there's no reason to. We have calculators that are much faster than we are at doing these operations, and I suggest you use them. But just to show you the process, 8,410 plus 38,587. You can write this vertically, and I'm going to line up the place values. That's the key thing to do here, is that we have the ones, the tens, the hundreds, the thousands, and then the 10,000s. I can just add a 0 for this one if I wanted to, but I don't need to. Then all I'm going to do is I'm just going to add going straight down the place values. So I'm going to start with the ones. 0 plus 7 is 7. 1 plus 8 is 9. 4 plus 5 is 9. And here I have 8 plus 8 is 16. So 16, this would be thousands. So 16 thousands is going to be 6 thousands and a 10,000, right? 16,000 is a 10,000 and a 6,000. So really we have the 1 is going to go up into the next place value because that's how big it is. It's just a 10,000s place value. So I'm going to carry that 1 up here. I'm going to keep the digit that I had, the 6 and the 16. I'm going to keep that in the thousands spot, but then I carry the 1, and now that comes 1 plus 3 is 4. So I have 46,997. Now this is going to be useful for subtraction when we talk about doing the subtraction here for places where I can't subtract, which we will see here in just a moment. Once again, I have lined up all the place values. 6 minus 1 is 5. 1 minus 2, well, I can't do that, at least not right now. You can do that, but we're not discussing negative numbers yet. But 1 minus 2, the way I can rectify this is that I need to borrow from the higher place value. This is always going to be, between the place values is always 10 digits. So this is 10 times. And then this is going to be 10 times. And then this is 10 times. So they're always 10 times bigger than the last one. So if this place, this is 1 tens, and this is 2 tens, I can't take 2 tens away from 1 tens, but I can borrow some from the hundreds place. I make that 0, and then 100 is 10 tens. So this becomes, instead of 1, becomes 11 tens. 11 minus 2 is 9. Okay, now we have 0 minus 9. Well, I can't take 9 hundreds from 0 hundreds. I need to borrow once again. I'm going to borrow from the thousands, borrow 1 from there, and now we have 10 hundreds. 10 hundreds is the same thing as 1,000, so we're going to have 10 now here. 10 minus 9 is 1, and then I can continue. I can't take 7 thousands from 6 thousands, so I'm going to borrow from the 10 thousands. 9 10,000s becomes 8 10,000s, and this 6 becomes 16 thousands. 16 minus 7 is 9. Then I have 8 minus 4 is 4. And then all of these are just zeros here. So I'm going to have 4, 8, and 6. Let me fix that. And that gives us 68,449,195. So what I'm trying to show you here is that all we're doing is we're just looking at the place values, or borrowing if necessary from higher place values to do the operation. You don't have to do this by hand. You can do it on the calculator. It's much easier to do on a calculator, so I suggest you do that. Okay, for multiplication, going vertically, we're going to look at each place value and multiply it through. This comes from the idea that 15 is really the same thing as 10 plus 5. 5 ones and 1 tens. With that being the case, what I can do is I can multiply 5 through 601 and then 10 through 601. And the way we do that in this format is we're going to go 5 times 1 is 5. 5 times 0 is 0. 5 times 6 is 30. I'm just going to write 30 down for that. Once I take care of the ones place, I'm going to show that we're talking about the tens place by adding a 0 here. And then continue the process. 1 times 1 is 1, 1 times 0 is 0, 1 times 6 is 6. And here we're going to add going down. Once you finish that process, you're going to add going down. 5 plus 0 is 5, 0 and 1 is 1, 0 and 0, 6 and 3 is 9. So we get 9,015 when we do this operation. Okay, finally, division. We're going to write it in this format. We're going to have 416 is what we're dividing, and we're dividing it by 5. And here we're going to ask, how many times can 5 go into the 400s? Not really 400s. We're asking really about the digit. We're going to take care of the hundreds by continuing the process. So really we're going to ask, how many times can 5 go into 4? It cannot. So now we're going to ask, how many times can 5 go into 41? It can go in there 8 times. 5 times 8. 5 times 8 is 40. So I'm gonna always line up the numbers that I have. I'm gonna line up from the leftmost and going right. And I'm going to subtract. 41 minus 40 is 1. Then I can bring down the next digit. 5 can go into 16 3 times evenly. 3 times 5 is 15. And I subtract and I get 1. There's no other number here, so this is where I stop. I have a remainder, that's what this is, a remainder of 1. So 5 can go into 408 and 16 83 times evenly, but there remains a single value left. Okay, if you do this on a calculator, this is going to end up being, it's going to show on the calculator as 83.2. This 0.2 is the same thing as the remainder 1, but this 83 is what's shown right there in the calculator. Once again, just do this on a calculator. For any large numbers, you should just do that. For small numbers, you should be quick enough to add and multiply. Like for one-digit numbers. There's no reason to use a calculator for that. You should understand how to do those in your head. And the better you can do those in your head, the better you're going to be at mathematics in general, because addition and multiplication and in turn, subtraction and division are fundamental to so much of mathematics.